Hello everyone, and welcome to our project's overview. Today we are excited to share with you our journey in creating automatic land cover classification system through integration of artificial intelligence within Lift software. And now let's dive in. So first of all, we have to identify the challenge in our journey when it began to create a system for land cover classification and making it accessible and user-friendly for Lift users. This was also the basic idea. And for modifying the Lift software capabilities to remove the traditional land classification process, which is labor-intensive and probable to human errors, and also quite time-consuming. And so the objective was to enhance the Lift software with AI to automate and improve accuracy in land classification. So our basic idea or our solution was to develop software extension in software that minimizes users' input and maximizes output accuracy, and to utilize satellite imagery and advanced algorithm for precise land classification, which we developed for build-up detection, rural, forest, and water areas. And the user would simply define the area, select land type detection, one of those four, and let the program handle the rest. So the development process it was in 4 phases. First was to prepare the data, so data preparation, where we got satellite images from Sentinel to satellite, where we pre-processed them and annotated them in our Lift software, where we used hand classification with semi-automated classification with method region growing. Then we annotated the images and we prepared the input for AI4Copernicus service utilization, where we trained our models for land cover detection, and the output was a raster image with probability values, and we needed to interpret the results for in user-friendly way, and also to integrate within Lift software the developed solution. For utilizing AI4Copernicus service to bring this version to life, we chose, of course, AI4Copernicus service, and it's specifically a deep neural network for pixel level classification of Sentinel-2 patches. We used this one because it was most appropriate for land cover detection. This service provided the necessary tool and capabilities to develop a model for our needs. And in this graphs, we can see the validation loss value for all training models. As we can see that for water and build-up areas, the detection was most successful, and the best job for predicting the build-up areas is built up in epoch 54, and with a combination of bands was to use all Sentinel-2 bands. But for rural and forest areas, we got sufficient results for some tasks, but for precise detection, those two aren't capable enough. So further improvements are needed for the rural and forest detection. And then we needed to implement the solution in our Lift software, so to integrate it within a Lift analysis tool and to create the process leading to faster and more accurate results. And now we're gonna look into the process. So we have the tool where we select AI4Copernicus, then we input some name we wanted. We select statistical area, which is here Ljubljana with border municipalities. Then we select the model name and define the area. And as a result, we get detection in detection results layer group. We get 4 separate layers for every model. For the build-up, as we can see, the prediction is quite good. It's sufficient for our case. And for rural detection, it got quite a lot of detected forest, which is bad, inaccurate. For water, we can see the detection was good, but it didn't predict all the rivers. all the river areas. For forest, for some tasks, it's quite sufficient, but an example for detecting the changes in forest areas, it's not accurate enough. And to continue our achievements and future plans, our achievements are very successful. So we created processed and annotated satellite images for model training, which is crucial for this task. Then successful AI4Copernicus service utilization for deep neural network training. In here we obtain 4 models for build-up rural forest and water detection, and we implemented this in our software. And we also created reports, this video pitch, and publishable summary, with which we can present our results and our project to relevant stakeholders. And some future plans, further improvement on prediction models capabilities, and introduce a new extension to current and potential users of the LIFT software. And in conclusion, we have successfully built a land type classification system within the LIFT software, offering a robust, reliable, and user-friendly solution. We extend our gratitude to everyone involved in this project, and we look forward to future collaboration and innovations. And special thanks to AI4Copernicus team for their valuable help, guidance, and resources. And thank you for watching our project overview. For more information, feel free to reach out to us.